Hello everyone, today we're going to be talking about the terminal velocity. Therefore, I prepared a little experiment in which we're going to drop a sphere, a solid sphere with a certain mass, into a liquid. In this case, the liquid is soap. Now that you have seen the experiment, let's continue. As you see in this graph, the terminal velocity is the area encircled in red. This is because the acceleration eases up over time. During terminal velocity, the weight of the object, which is the mass times the gravitational acceleration, minus the buoyancy force, minus the viscosity force, and minus the drag force, equals 0. Here you see the analogies and the correspondences. The weight force being mass times gravity, the buoyancy force, density of the fluid, times its volume times gravity, the viscosity force, which is 6 times pi times the viscosity times the radius times the velocity, and the force caused by the drag, which is 0.5 times the drag coefficient times the density of the fluid times pi times the radius to the power of 2 times the velocity to the power of 2. To some of you, this structure here may seem familiar. Let me give you a hint. This is a quadratic equation, just like this is. Here are the analogies. The elements underlined with a red correspond to those on the bottom that are also underlined with a red, and so do the other colors correspond to each other. This, for example, would be the A, this would be the B, and this would be the C. Let's start simplifying all these little terms here. Let's start at the C, this one here. mg minus rho times v times g. In our case, our fluid has a density of 1070 kilograms per cubic meter. And to calculate the volume, we will have to use the radius of 0.0065 meters, which is 6.5 millimeters, to the power of 3, times pi times 4/3, and this term in the brackets, between the parentheses, is the volume. All these factors multiplied with each other are the buoyancy force, and this is the weight. And the buoyancy force will be subtracted from the weight. Then, let's take on the B times x. This is the force caused by viscosity. It is 6 times pi, which is 3.14, times the viscosity of the liquid. In our case, it's 9.343 Pascal seconds, times the radius, which is 0.0065. And the v is our variable. And last but not least, the A times x squared. This is the force caused by viscosity. It is 0.5 times the drag coefficient. In our case, it's a sphere, so it's around 0.5 or 0.47, times the density of the fluid, which in our case is 1070 kilograms per cubic meter, times pi, which is around 3.14, times the radius of our sphere, which is 0.0065 to the power of 2. Calculating all these coefficients will leave us with a quadratic equation of 0.066 minus 1.144 v minus 0.033 v to the power of 2 equals 0, because we're trying to find the v, which is in our case the spot where the function touches the x-axis. In order to solve this quadratic equation, we will have to use the PQ formula. There are other ways, but I will address them in another video. Therefore, we need to divide minus 0.033 to get the coefficient here to positive 1. Now it's minus 0.033, and we'll get it to 1, which leaves us with minus 2 plus 34.6 period v plus v to the power of 2. Now we can use the PQ formula, and we'll insert this term in there, which leaves us with minus 34.6 divided by 2 plus or minus the square root of 34.6 divided by 2 and all this to the power of 2 plus 2. In our case, it only makes sense to add the square root and not to subtract, because we can't end up with a negative velocity. As I said, I'll do a video on how to solve these equations. And all this leaves us with a terminal velocity of 0.0577 meters per second. And that's it for the video. If you like the channel and want to see more every Saturday, then feel free to subscribe. You can always change your mind, and it's totally free. If you wish to give me feedback or have any suggestions for this channel, feel free to share them in the comments. See you next time.